All right, so here's a think, pair, share. Pause the video, try this one on your own, and come back, if you want to see me work on this. Okay, so a Gallup poll in which 1,487 adults were surveyed, 43% of them said that they have a Facebook page. Find the 95% confidence interval estimate of the population proportion. Based on the results, can we safely conclude that fewer than 50% of adults have Facebook pages? All right, so ultimately, this is going to be the question that we're going to try and answer, but we can't answer that until we get our confidence interval. So as always, let's start by identifying the given information in this word problem. So Gallup poll in which 1,487 adults were surveyed. That is our sample size. 1,487. Now, 43% of them said they have a Facebook page. So 43% is actually our proportion of successes. We want to write that as a fractional value. So we're going to write that as a decimal equivalent of 0.43. Find the 95% confidence interval. Okay, that tells us we've got a confidence level of 0.95, which means a significance level of 0.05. And because we're dealing with confidence intervals and we need to take the significance level and break it over two tails, we need to divide the significance level by 2 until we get 0.025. All right. So I guess one thing we could calculate here really quickly is we have P prime. We're going to need Q prime, which is 1 minus P prime. And remember, your calculator is probably going to use hat. Okay, it means the same thing. So 1 minus 0.43 is going to give us a proportion of failures of 0.47, 57, 57. There we go. All right. So what do we need in this problem? We need a confidence interval with a point estimate and margin of error. The point estimate, now we've got. What we need is the margin of error. So that's going to be equal to our Z alpha 2 score, which is our critical value score, times the square root of P prime times Q prime divided by N. And we've got, P prime from earlier. We have Q prime. We have N. What we don't have is our Z alpha 2 score. So let's go ahead and figure that out here off to the side. This is our positive Z crit score, negative Z crit score. Now, if you're starting to be able to do this in your sleep, that's good. I want this process, like firmly embedded in your statistical brain here. Okay, so the area in each of these tails is 0.025. We want to get these critical values that borders the confidence level and the significance level. So we'll use our inverse distribution function to convert an area to a value here on the number line. And I think because these are the same values as before, clear that. I'm going to have the same values in there. Yep, 0.025 and the area to the right. There we go. So we get 1.96. All right, but I'm going to want to store that. I'll store that into the letter capital Z. So I'm going to put store capital Z. There we go. Let me go over here to the NumWorks calculator and make sure that I do the same. Distributions, normal, 0 and 1, area to the right, 0.025. Okay, this is left over from previous. But I'll just go through the motions here. Gives me the same number. So I want to store that also in capital Z. There we go. And I can come back out, go to the calculation. And yeah, I'm gonna do the same thing I did in a previous calculation. So let's say I want to bring out variable Z. Then I want to do the square root. And I'm going to put the numerator in parentheses. So it's going to be 0.43, which is P prime, times Q prime, which is 0.57. So 0.43 times 0.57. 0.43 times 0.57, right parentheses, divide by the sample size, which was 1487. So 1487, like that. Texas Instruments. Let me try not putting this in parentheses. So let me put Z, square root, numerator, 0.43 times 0.57 divided by, I think that was 1,487. Yeah. Okay, go ahead and exit out of the square root and get rid of that. Then click enter, come over here, hit execute. Yeah, we get 0.025 and some change. Okay, so let me go ahead and put in my values. Because if you do too much in your calculator, you won't have enough to teach yourself how you did this before. And it only takes a second to put these values in. So that you can teach your future self what you did. Okay, and this came out to 0.025 and some change, which rounded to 3 decimal places is just 0.025. All right, so now we can construct our confidence interval, which is the point estimate of 0.43 plus and minus 0.025. All right, but we want to be able to evaluate it to see how it compares to 50%. So if we're going to write this in percentage, this is going to be 43 plus and minus 2.5%. Okay, that's the equivalent there. And if we're going to put this on a number line, right, so we've got 10%, 20%, 30%, 40%, 50%, 60%, so on. Then what's this going to be? Well, our population proportion looks like it's going to be between 43 plus 2.5. Come on, computer. Okay, 43 plus 2.5, which is going to be what? 45.5. And then 43 minus 2.5, which is going to be 40.5, right? So our interval is going to be between 40.5 and 45.5, something like that. So the question was, based on the results, can we safely conclude that fewer than 50% of adults have Facebook pages? So here's 50%. Can we safely say that fewer than 50% of adults have Facebook pages? Well, with a 95% confidence interval, our entire interval is below 50%. So the answer is yes, that with a 95% confidence level, one can say, let me scroll this down a little, one can say less than 50% of adults have Facebook pages. All right, so this concludes this example. Let me know if you have any questions.